Here's the video recording for online probability and stochastic process homework 2 by page 110. And this is problem 2. The problem setting is the signals are input and output through a series of noisy channels where the starting signal is denoted as x1 and the kth channel has an input of xk and the output of xk plus 1, and the output of the kth noisy channel is supposed to be the input of the next noisy channel, and there are several probabilities given. The first is the starting signals where x1, when x1 equals to 0, the probability equals to 0.2, and the probability of x1 to be 1 equals to 0.8. And for all k between 1 and n, the probabilities are listed here, where the input signal of the kth noisy channel is equals to 0, and the output of this kth noisy channel, which is xk plus 1, and equals to 0, and this probability equals to 0.6. Similarly, when the kth input, which is xk, equal to 0, the probability of the output xk plus 1 equals to 1 equals to 0.4. And similarly, we also have these two. When the xk equals to 1, the output signals equals to zeros and ones, which are separately 0.3 and 0.7. And the first question wants us to find p, where x2 equals to 1. And this probability can be easily found by multiplying these relative given probabilities and add them up together. So when the x2 signal equals to 1, there are two different situations, where the first situation is when the first signal x1 equals to 0, while the probability of x2 equals to 1 take the value of p x2 equals to 1, while x1 equals to 0. And similarly, the second situation is when x1 takes the value of 1, and this probability should be multiplied by the probability where x1 equals to 1 and x2 equals to 1 as well. And these numbers are the values of these probabilities, which are 0.2 multiplied by 0.4 plus 0.8 multiplied by 0.7, and these adds up to 0.64. That's the solution for the first A question. For the B question, it asks us to find p x3 equals to 1. So similarly to the first question, we can find the px3 equals to 1 equals to two different situations adds up together. The first is px2 equals to 1 multiplied by px3 equals to 1, while also x2 equals to 1. The second situation is where px2 equals to 0, and also the probability of x3 equals to 1, while x2 equals to 0. And actually, we don't know all of these values for these probabilities in this equation. So, but we do know the probability of x2 equals to 1 is equals to 0.64. So, similarly, we can find the probability of x2 equals to 0, which is also divided into two different situations, while also I have obtained a much easier way, which is to divide the probability of x2 equals to 1, which is 0.64, by 1. So the probability of px2 equals to 0 can easily be obtained from 1 minus 0.64, which is exactly 0.36, which is in coordinates with the results we have obtained here. And for the probability of x3 equals to 1, we can just introduce all of these values of px2 equals to 0 and px2 equals to 1 into this equation, and we get 0.64 multiplied by 0.7 plus 0.36 multiplied by 0.4, and which we get the result is 0.592. That is the probability result value for the x3 equals to 1. And for the third question, it asks us to find when x3 equals to 1, but the first signal x1 equals to 0. And due to the, according to the properties of conditional probabilities, we can rewrite this probability as the probability of x1 equals to 0. Meanwhile, at the same time, x3 equals to 1, and we divide this probability by the amount of p x3 equals to 1, and in this case we can get the result, the probability result which we are asked for. And so if we see the next page, we can see that this equation is rewritten here again, and to find the numerator of this equation, we can rewrite this probability as px1 equals to 1 multiplied by the a sum of these two different situations, which is basically when we are trying to find the x3 signal to be 1, and we divide all of these equations by px3 equals to 1, which we just obtained from problem B. And these are and we take all the values in it, and it should be 0.2 multiplied by the sum of 0.6 multiplied by 0.4 plus 0.4 multiplied by 0.7, and it is all in all divided by 0.592, and the result we can get is approximately 0.176. And the final question asks us to find the limits of the probability of xn equals to 0. And as we can see from the problem setting, since xn equals to 0 is like a combination of these two different situations, which is like similar to the first and second question of this problem. So we can rewrite it in terms of all the values we already obtained. So we can get the bracket 1 minus p xn minus 1 equals to 0, bracket multiplied by 0.3 adds px1 minus 1 equals to 0 multiplied by 0.6, which can be found out as equal to 0.3 plus 0.3 multiplied by pxn minus 1 equals to 0. So we can get a relation between pxn equals to 0 and pxn minus 1 equals to 0. And we rewrite it, we can get that the probability of xn equals to 0 minus 0.3 is equal to the n minus 1 root of 0.3 times px1 equals to 0. And finally we can get the situation, the equation as this, and px1 equals to 0 is actually 0.2 as given in the problem setting. So find the limitation of this pxn is equal to 0. It's very easy to find when n is approximately infinity. We can find the limit to be 0.3, and that is the result for the fourth problem. Thank you.